Welcome everybody to the 8th and final COVID-19 Robots and Us weekly discussion with experts. Why the final? Because the COVID crisis isn't over, but the bulk of our response to the crisis is definitely starting to shift away from innovation that's community-based into more large scale, more coordinated efforts. And we're going to be focusing our next online efforts at Silicon Valley Robotics, that is. We've got a couple of other directions that we really need to explore. So next week, we're going to be hosting Open Problems for Robots in Surgery and Healthcare. It's a free mini symposium on the latest in advanced robotics research and applications, with speakers like Gary Goodhart, the CEO of Intuitive Surgical, Alison Okamura and Munro Kennedy from Stanford Engineering, David Noonan from Auris Technologies, Tom Lowe from SRI International, and Jaydev Desai, who runs the Georgia Center for Medical Robotics, and Ken Goldberg, who will be on our discussion later tonight from CITRIS and the Center for People and Robots. And before we kick off, I want to thank our fabulous crew, Bo Amber from Kickstarter, who's manning the Zoom, and Erin Pan, who is manning the questions in chat and link sharing. And also, if you happen to have an autonomous vehicle opportunity, I think she'd be interested in hearing about it. Final housekeeping for everybody. If you're not a speaker, please keep your video off and your mic on mute. If you have a question, please put it into the chat. We'll be monitoring it and we'll be doing Q&A after the introductions. But what we're going to do first is spend a little bit of time with David Crawley from Ubiquity Robotics, and we'll go straight into a few questions and answers for David because it's the middle of the night where he's calling from. So we'll let him get back, get some rest after his section. And then we'll talk to Dale Dougherty from Make Magazine, Tra Vu from OhmniLabs, Alder Riley from Helpful Engineering and the MASK Project, Mark Martin from California Community Colleges and Bay Area Manufacturing Discussion Forum, possibly Guy Cavalcanti from Open Source Medical Supplies, if he's got some time, and Ken Goldberg, the director of CITRIS People and Robots Initiative. And I'm Andra Keay. I'm the director of Silicon Valley Robotics and the founder of Women in Robotics. And it's my pleasure to moderate our final COVID-19 Robots and Us. Now, David, over to you. Please tell us about Ubiquity Robotics.
Thanks. Before we start, really building disinfection robots, it's more than just business for me. I am from a high-risk group. I can tell you what viral pneumonia is like because I've had it several times. I have an atypical asthma that causes this to occur to me all the time. So that's something that occurs to me all the time. If I can just share my screen. I'm going to talk a bit about Ubiquity Robotics and then something about the disinfection technologies and talk a little bit about some of the example robots that Ubiquity is building. Everybody wants to get into mobile robotics, but when they do, they realize it takes them some 2 years and somewhere between $500,000 to $2 million to just build the basics, mobility, navigation, payload, AI, object awareness, compute infrastructure. Ubiquity Robotics produces a low-cost platform, Magni platform, that enables you to get to market fast. And because we are really focused on helping people get to market fast, we've been quite busy over the past few weeks. We've been getting many calls, some days as many as 3 new inquiries per day, for people to ask us to help them build disinfection robots. And what are people trying to do? Well, they're trying to prevent disease transmission through what are known as fomites. Fomites are surfaces that transmit disease. People cough, sneeze, simply breathe viral particles out, and those viral particles settle on surfaces around you. And SARS-CoV-2 remains viable on those surfaces for some period of time. I mean, it remains viable on steel and plastic for more than 72 hours in some studies. People obviously touch those surfaces and then touch their face, and thus become infected. It's known to be a significant transmission route was known to be a significant transmission route for other coronaviruses, namely SARS. And it's a very important transmission route. And that transmission route obviously can make a lot of people sick. It can increase the RVAT, the reproduction rate, the likelihood that any one person infects other people. And so it's, so really the key question is, how do we go about disinfecting all of those surfaces and making the environments in which we are in safe for people? Well, obviously one answer, there are many ways of going about that, but one answer is using conventional disinfection technologies. I broadly divide them into two different camps. I divide them into energetic disinfection and chemical disinfection. In energetic disinfection, you have various kinds of UV robots, UVC, UVB, DUV. These are all different types of UV light. On the chemical disinfection side, you have vaporized hydrogen peroxide. You have some other mechanisms that I can't disclose because I'm under NDA. You also have ozone. Now, if you look at the different types, the ones that are listed in bold are ones which Ubiquity Robotics has active programs in right now. We have customers that are coming to us and asking us to help them build a robot in those technologies. So, we actually already have customers who are working with us right now to build UVC, UVB, DUV, vaporized hydrogen peroxide, and ozone robots. As I said, we've been rather busy. The reason why you want a robot is because most technologies that kill germs are harmful to humans too. And you need a robot to deliver disinfection to prevent danger to people. Obviously, you want the robot to be spraying these unpleasant chemicals around rather than a person, because, if you have a person spraying unpleasant chemicals, it's a risk to the human. At the very least, it's unpleasant. UVC, UVB, and DUV, they're UVC and DUV cause cancer, so you really don't want people around when you're running those systems, or at least not too close. Does that make sense so far?
Sounds great, David. And I'm impressed that you're covering 5 out of 6 of the disinfection technologies already.
Right, 5 out of 6 of the ones that are listed here. Obviously, like I say, there are others that I can't talk about, but yes, some people want joint systems. I'm only going to be able to, I don't want to spend a long time dwelling on the robots that we're building. I can't really cover all of them, but I thought I'd just talk about the top 3, and then we can talk about what we're doing in those spaces. The top one obviously is UVC, one that a lot of people want to are very interested in. We are actually collaborating with a European customer to build a robot kit for this. So this is what that robot kit looks like. Fairly standard multi-lamp solution. Sits on top of the robot drives around, and so forth. Left is one of our early prototypes. On the right is what we expect the finished robot to look like. And in this case, we're simply going to sell the Magni or our robot with the kit. You can attach your UVC lamp to it. You can add in your own software, your own cloud integration if you want, your own remote and navigation capabilities, and go ahead and try to attack the problem that way.
Now, David, just a quick question. Are you having supply chain troubles? Because these UVC lights are in such demand now.
So yes, that's a really great question. We have, like everybody else, had a whole series of supply chain disruptions. Obviously, we've had a whole series of supply chain disruptions. In general, however, we have been able to overcome those issues. In terms of our supply chain early on in the pandemic, our supply chain is very clearly focused on in southern China. We had a lot of difficulty early on. I think since the early days of the pandemic, the situation in China has gotten a lot better. And we have tried to design our supply chain for robustness. If you go online, there's a YouTube video called How to Supply 1,000 or More Robots, which talks about supply chain issues related to robotics. It was obviously one that I was a talk that I actually gave and hosted about how to set up your supply chain in advance for resilience. So we've been okay up to now after some initial blips early on in the pandemic. Okay, so we have a UV disinfection kit. The one that I'd really love to talk about is Robot X. Unfortunately, we are still about 2 weeks away from a press release on this one. And because I'm under NDA, I can't disclose too much. However, this was a custom-built magnet to target a fairly specific requirement. We're using a chemical. In fact, we did a full-up mechanical redesign of our robot to be able to target the specific domain, and we did it in about 6 days. It was a kind of crazy project. Which is why, getting up at 3:45 a.m. local time is not such a big deal as compared with this project, right? And it uses a chemical disinfection technology. It's this project was jointly done with a customer with deep experience in disinfection. So we partnered with a company that has a number of existing products that are in the disinfection domain. They approached us and wanted to do a disinfection robot together, and we custom designed a robot for them to enable the ability to traverse all kinds of different domains that Magni was not really ideally suited to. In particular, narrow aisles. So you can maybe guess the sort of environments we're tackling there. Finally, we have another system that I'm doing here in the US, which is disinfection for janitorial. This is going to be based on our bog standard Magni platform, again, using VHP. And it's targeting janitorial cleaning. Those are just some of the robots that we're targeting. Like I said, we also have DUV robots. We also have we're targeting also combination robots. There's one requirement that we have for a UVC plus VHP system and so forth. So questions. I mean, Andra, I don't know if you have any questions about this. What people often ask me is which technology is best. I mean, that's a fairly sort of common question. Maybe I can shed some light on that, or I don't know, Andra, are there other questions coming through in the chat?
Yes, there's a question from Alder, which is, how does your system compare with other mobile robotic systems that you can potentially get in retail, like perhaps modular kits? And can you adapt to working with other robots that are already in public spaces? And I think I'll split that into two questions, because I think there's a really big question in there as well. So firstly, what is Ubiquity? What is the Magni base compatible with in terms of adding things on?
Yeah, so the Magni base is, it's a ROS-based robot. We were one of the very, we were a robot that started with ROS. It's our 5th generation design. So you have a full ROS stack there. And what we try to do is enable our customers to build full robot applications, with prototypes appearing in a matter of hours. If you look at our website, we have a number of applications on the website. You can see videos of us doing things like drink serving robots and other types of robots. All of those were applications that we put together in less than 10 hours before we went off and shot the video. And so because of the raw stack and because of the way in which we have worked hard to expose all the sensors and systems on the robot to our customers, we really can provide you with mobility and navigation, power, compute, and payload, and we can provide that to you so that you can program your robot literally in a matter of hours, and get going on your application very, very quickly.
Now,
Not only, yeah.
I was going to say, I've been a huge fan because you've created a robot workhorse that is something that I believe pretty much you're servicing the long tail of robot adopters. And that's a space that people just haven't really been dealing with. People have been going, well, this is our proprietary robot doing this particular service. And you have created a platform and you've stuck your guns to creating a platform, although I know that's often not considered the most lucrative kind of robot to do, but you are doing a great thing with making robotics accessible. Now, I don't know how much you can tell us, but just roughly speaking, what kind of multiples do you provide Magnis to customers in? Is it like one Magni per customer, or is it hundreds of Magnis to a customer?
So we do the whole range. So we really try to make it Magni available within, what we say is 2 weeks delivery within anywhere in the world. So you can actually go online, but you can actually, go online and buy a Magni, and we'll ship it to you wherever you are in the world within it's usually more like 4 days for customers in the US. So you get a 100-kilo payload raw space robot, which is powerful enough and big enough, has enough payload for you to actually build a real application on, and you can get it really, really quickly. Which is why I think we've been busy since the start of the pandemic, because of the exigency of these requests. We supply them in single units, but we can also supply up to 150 units a day. So, and there are customers who do need it in the dozens and dozens of units, and we do supply it in dozens and dozens of units. So we cover the whole spectrum from, you want to buy a single unit Magni, you can get it very quickly, because we feel like that's important for anyone to be able to develop their application. They need to be able to get the base platform. And they need to be able to get the base platform extremely quickly. We do have customers who order dozens or hundreds of these things. And also, if you want to have dozens or hundreds of robots, then we can also help you build a custom robot yourself, put it into the supply chain. We can actually do that very, very quickly too. So some people want to have custom widgets or custom accessories. We're capable of doing that. I just did one yesterday. We had the request yesterday, and we're going to try to get the first finished tested units of a Magni plus some additional accessories and new, and we're going to try to get that done for them in a month. Maybe there'll be some slippage in that, but that's kind of what we have from a supply chain perspective as well. That's new software, new sheet metal, new covers, new other bits and pieces, going from an idea to something that they can actually use, and actually produce in large quantities in only a few days, really. So yeah.
That's a massive undertaking. That's incredible. Quite a lot of questions for you, in fact. The price point is got people going, what? You're kidding me. That is amazingly affordable.
Right. Yeah.
Bravo from David.
Right. Yeah. Well, we sell the robot at 1,900, and we've always been focused on price, right? We've always been focused on, because we originally started as a group of guys who wanted a capable robot for our own projects, and we sort of looked out there and we said, well, you really can't get a decent 100-kilo payload ROS-based robot for under 5 figures. And we felt, well, that's kind of crazy. We should be able to do that. And we initially set a target of building one that was affordable for us as hackers in the garage. As a practical point, we feel like robots cannot expand beyond a few niche applications unless the cost of the robot plus the system plus all of the attachments and everything else is below about 8K. So we make the base robot available for 2K. We expect a few extra K in accessories and systems and other things that, other people will put together, and then you can have a robot that is cost competitive against minimum wage worker anywhere in the world. Pretty much, it's the idea.
Yeah,
so
I agree. We've got the cost effectively of a full robot system, mobile base, articulated arm, and end effector for sub 10,000 K now. If you partner Magni with, say, Sake Robotics end effector, and either like a Haddington Dynamics or an Automata robot arm.
Yeah.
I'm still waiting on some of the others to come out that were promised me a couple of years ago, but it's still incredibly affordable. A backlog of questions now. I'll just start with Marianne Williams, and I know she's in Australia, ANO Robotics Lab. Wants to know, would you like university partnerships, or do you do that?
We do university partnerships. We do work on those. I mean, in terms of the disinfection robots, what we are trying to do is, we want to get disinfection robots out to everyone who wants them in every niche that people want them. And so what's tending to happen with disinfection robots is, I'm getting a lot of calls, and I'm trying to direct those calls to a set of partners who are capable of providing the system. So we're not reinventing the wheel. So we have, for example, people who want a standard UVC system. That's why we work with Engmotion to create this module for Magni. They wanted to produce a module and sell it to their market. And I said, well, I've got all these other customers who want to have a UVC system for their various end markets as well, and their specific applications. So I sat down with Engmotion. I said, look, let's make a module that attaches to Magni, and then we can sell the Magni and you can sell a module, and people can apply that to their own environments. And then what we've done is taken that module, and we've partnered with a whole bunch of other people who have been asking us for UVC systems, so that they're not redesigning what Engmotion has already done. And that's what we're tending to do on the partnership side. We're trying to essentially channel the partnerships through a series of, we're essentially trying to create a set of consortiums around all the various different technologies, so that we're not reinventing the wheel. Now, not everybody wants to do that. Some people want to have a custom robot for their own thing and their own domain, and they want to go off and do their own custom thing. We're happy to support that too. And they want to have it completely proprietary, and that's what they want to do. I mean, RobotX is that kind of a deal. But in general, we're trying to make sure that we have essentially consortia to partner in any given technology, and try to keep the technology duplication low. So yes, absolutely delighted to talk about university partnerships, and we would probably ask them if they want to participate in one of the consortia that is most interesting to them.
That's excellent. Marianne has added that she works with 7 hospitals in Sydney.
Oh,
so
fantastic.
I will connect you for sure. Now, there are a number of other questions, a couple of which relate to things like the UVC coverage. Like, is there sufficient power, and how do you deal with shadowed areas?
Right. I mean, this is one of the reasons why we're dealing with multiple different technologies. I think, when the pandemic struck, everyone was like, oh, UVC disinfection robots, UVC disinfection robots. But, for many environments, UVC is not suitable because of those sort of concerns, that you have to really be able to know your distance away from all the surfaces in order to be able to get the dosing right. Because you have a power law reduction in dosing power the further away you get from the robot. So it's not going to be really good enough to simply have a UVC lamp sitting on top of a robot and and just sort of drive around randomly and expect to get good UVC disinfection coverage. In those sorts of environments where you don't really know how far away you are from the surfaces, we strongly recommend people to consider chemical methods such as VHP or fogging for those very, very reasons. The other issue, of course, is power consumption, and UVC, obviously, because it's an energetic method, like all energetic methods, has a huge power consumption. Fortunately, Magni has a fairly substantial onboard battery capacity. We designed it for this reason because we didn't know what people were going to plug into it.
And you can carry a lot of extra batteries. I mean, that's Magni's
right.
workhorse.
We can carry a lot of extra batteries. The system was designed around a 12350 battery, which is if you think about a 2-hour mission for the robot, the 12350 battery, the robot only consumes 5% of the 12350 battery's capacity, which leaves 95% for plugging into a giant UV lamp or whatever else you happen to want to plug it into. And we designed it for that purpose. We designed it because we wanted to make sure that people didn't have to worry about battery capacity. And of course, we have all the safety systems and onboard power management systems available on Magni. However, I do recognize that UVC systems probably are not going to be suitable if you can't do your mapping and driving behavior so that you know how far away you are from the surfaces and can ensure appropriate dosing. And so therefore we would, if you are not in that sort of happy situation, we would tend to suggest that a VHP or a chemical-based method would be a better technology for you. And we sort of direct people to our VHP offerings.
That's an excellent point, and there's a lot of questions about that. Mindful of how much of we've got 1 hour and we've kept you awake for a large part of it. Yeah. So my promise to let you go back to sleep. If I want to keep that promise, I think we'll end your section now. But your email was on the slides, and there's a few people that definitely want to get in touch with you and follow up.
I'll just.
So we'll make sure that we share that.
Yeah.
And I'll chase you down for the link for that. Was it how to scale to 1,000 robots? Video.
Yeah, that's how to produce 1,000 or more robots. It was a talk that I did at the Homebrew Robotics Club. So
excellent.
So there you go. All right. So that's my screen. You can see that's my email. Feel free to reach out to me at any time. Feel free to call me, and I'd love to hear more about what everybody's applications are. We love building robots. I'd just love to hear what we can do for you and how we can help.
That's wonderful. Thanks so much, David. And we've got the email in the chat now, so you can go back to sleep.
Okay, thank you.
Thank you so much. And now we're going to spend a few minutes with each of our speakers now talking about, particularly for those that were on our very first call, talking about what's changed since then and where things are going on now. But first off, we're going to go over to Dale Dougherty, who is going to join us. And he's been doing also a webinar on COVID, Plan C, the civic response. And I'd love to hear a little bit more about that, Dale, if you're there.
Yeah. Hi there. Thank you, Andra. Well, I have been writing a series of articles started with the idea of Plan C. If government is Plan A and industry is Plan B, and neither are working particularly well, we needed a Plan C, a backup plan for the backup plan. And that was largely a civic response of self-organizing groups coming together, and the maker community was kind of a model, in my opinion, for civic response. And in many ways, the 10 to 15 years that it's taken to build maker spaces and spread them around the world and in schools and libraries and communities, it was as though we were preparing for this very situation. And makers, and I even credit Neil Gershenfeld, the Fab Lab, MIT Center Brits and Atoms, of to some degree envisioning that digital files could go anywhere, and if you had the machines in lots of places to make something, you had a very efficient distributed manufacturing system. And so even though many maker spaces closed and many universities and all libraries closed, at least in the US, some absconded with 3D printers and other equipment, took them home. They called them liberating the 3D printers at DePaul University. And they began to just sort of build out their network. That you know, the makerspace wasn't just the physical space. It wasn't just the tools or materials. It was the people, the relationships that were there. And then that overlapped with other networks such as medical. And, you know, in the case of Chicago, they built a distributed nodes where there were many people creating, you know, face shields and other things. And then connected with the out of work bike messenger community and had them delivering the face shields to the homes of ER doctors, because you couldn't deliver them directly to the hospital, but you could deliver them to a doctor who would walk it into the hospital and use it. So a lot of really clever, interesting, innovative ways of making change and responding to the crisis. And I just found it really fascinating, both the human story that of how people work together, often on a volunteer basis, and usually in an open source, you know, fashion of sharing designs and seeing them spread around. So I've been writing about it, profiling sort of how some of the designs come together, how they're being produced at scale, and even some that are, you know, began as 3D printing, they're prototyped a lot, and then they go into be injection molded and other processes to get to scale. But I'm just doing that. So I mentioned that Tuesday and Thursday program called Plan C Live, and thank you for being on it today. Andra, we talked about UVC light units, and particularly low cost open source projects is what we're interested in here, DIY and other natures. And I just, one other thing is, this weekend would normally have been Maker Faire Bay Area, would have been our 15th edition. And mostly it's raining today, just like it rained last year on this weekend, which is a little bit hard to take. But we hadn't planned to do it for a number of reasons, but we are doing something called Virtually Maker Faire on May 23rd. Because it's using technologies like Zoom and Hangouts, it'll be distributed around the world for 24 hours, starting in Asia, and then Europe, and then coming to the Americas. And it's really just consists of video sessions that people self-organize and offer to, you know, maybe do an open house from a community, share a solution they have. We particularly want to feature COVID-19 ideas and what people are doing. And it's, you know, not just the design or the product side, but it's really the community organizing side that I think is really important. How do you, you know, build teams of people to do this? So that's coming up May 23rd.
Oh, wonderful. Time has gone so fast.
Yes.
But recently, I can't believe that this is that time of year that would normally be Maker Faire.
Yeah.
But you've adapted to virtually. And we certainly discovered benefits of doing some events virtually, but yeah, it certainly.
I did a panel last Thursday on one of the popular face mask designs. It's called the Montana mask, you know, and, you know, I had not only people from Billings, Montana, but from San Diego and Pittsburgh and Bay Area and New York. And, you know, you just would have never had all those people together. Physically. And so it does allow us to connect. And I think that's, we still need those connections. I think that's what Maker Faire more than anything gave us. And so we have to kind of invent new ways to connecting people. Even people are working really hard on things like PPE. It's important to look up a bit and connect and find other people and share what you're doing.
It definitely is. And I miss that human connection. So getting it via Zoom is great, but also sometimes being able to come together for essential work, making PPE. It's
well, I agree, and I think, you know, the COVID-19. This is sort of the first wave that's hitting us in terms of medical supplies. There's many other waves I think that will hit, and we won't just be reopening. We'll really have to be rebuilding And I think these are models that we should understand. I wrote a piece a couple of weeks ago that I called Challenging Challenges, and I was kind of pissed off a little bit at seeing, companies announce design challenges and hackathons around COVID-19. And partly, they weren't paying attention to what was actually happening already, that there was a lot of innovation, a lot of grassroots stuff, but they kind of wanted it to come to them. And instead of going out and maybe offering some funding for the existing stuff to help it get off the ground. And particular organizations like government agencies, it'd be really helpful, instead of having a hackathon, is to start opening up about what your needs are and what the rules are. Like if you're the Veterans Administration, tell us what you damn well need, and put it out specs that help people build those things. Don't make us guess. Don't waste our time.
That's an excellent point. I would love to explore what you're writing about there, because we do. I think we're seeing a lot of innovation in our practices in the current. And I think that's actually a really great segue to Alder Riley from Helpful Engineering, who, well, Alder, you can talk more about this, but I know the experiences that both you and Keay have shared with me was being ready to solve the government's problems while they were still going, I don't know, can we find makers somewhere? Do you think they could help? And meantime, the community has already said, well, we're producing, we're making things, we're organized, So there's also some good things in chat, but Alder, are you there?
Yep, I'm here.
So you've been involved in volunteer groups making PPE since pretty much the beginning. What was it like then, and how has it changed?
Yeah, absolutely. So from the very beginning, it's very inspiring to see how the community has kind of come. And like Dale said, when government fails, when business kind of falls on its face, the maker community has kind of come together in this wonderful grassroots movement. So I'm involved in two organizations mainly, the Mask Project and Helpful Engineering. So I guess I'll start with Helpful Engineering since you mentioned it first. So Helpful Engineering is about 16,000 volunteers, organizers. We're all on a website, on a Slack channel, all over the world. We're basically a incubator of ideas. So you can come on to Helpful Engineering and say, I've got a really good idea for a 3D printable ventilator. And through, bouncing ideas around, we've got everyone from medical professionals to compliance experts to, all kinds of engineers. Crowdsourcing these designs has been really powerful. So we've really gone from, I joined it from a Reddit thread. So it was just really like, people just organically coming together to now a rather sophisticated incubator style. No funding is involved, but you can get your ideas out there. It can be, tested, gone over, and we've, developed a really broad scope of everything from face shields to, ventilators to O2 concentrators. All these things are kind of popping out of it, all open source designs. So they can be sent out to wherever they're needed, whether it's, down in Oakland, over at Circuit Launch, you guys are making a bunch of face shields, over to Portugal, where, we're helping them make ventilators, to down in Ghana, helping them make O2 concentrators. So it's been really, really powerful community. Since last time, we've mostly been concentrating on our international expansion. The community is mostly US based, but we're starting to get very strong communities in Africa, Asia, primarily India. Let's see. And mostly Helpful Engineering is like a resource. So, I'll post my email in the chat afterward. Feel free to reach out to me if you've got a cool project and you like to need help from, getting in front of some engineers or some medical experts. Send them my way. I love hearing about it. The other thing I'm involved in is the Mask Project. We're one of the projects that kind of spun out of the Helpful Engineering, where it's a matchmaking platform. So we develop these ideas to the point where they can be not commercialized, but pushed out to like professional manufacturers. So if anyone on the on the call has heard of the origami face shield design. That was one of ours. Now it's in production in the US alone. It's being pumped out in hundreds of thousands of units a week. So like, it's really, you know, it's prime time. It's getting into hospitals, it's getting into nursing homes. It's been really awesome to see how well it's moved out there. In terms of, let's see, since the last time we chatted, we've gone from kind of a, you know, outreach is definitely a thing that we're always looking for, because we've actually got call centers now that are reaching out to all the hospitals around the US, you know, just seeing what do you need. But, you know, we can't be in all places at once. So if anyone on this call knows of a medical facility or anything that might, you know, need some help, send it my way. Again, I'll post my email in the chat and, you know, send it our way, because we are always looking to help people, you know, get the materials they need, because we're all volunteers. We're all trying to just get things out there. We're all makers. So we'll work with you, whether, you know, you just got a laser cutter in your basement and want to, you know, pitch in, or you know, have a nursing home locally that you'd like to see if we can get a donation out there. So yeah, you know, happy to help however I can. And it's been really cool seeing the community adopt this. So
That's amazing, Alder. I am part of the helpful engineering community, and yet I had no idea of how much it had grown in the last 2 months. And, you know, I've just been focused on my local area, and the fact that you are able to provide these connections as far afield as Ghana and India, but also the fact that as a volunteer group, it's become organized enough so that people are doing, you know, I remember when it looked like it was a whole lot of people who all wanted to invent the mask. And the fact that people are doing the really important jobs that are far less glamorous, like calling hospitals and saying, hey, what do you need? Can we help? That is just incredible. Congratulations.
Yeah, it's been really cool to see. So.
And speaking of donations to hospitals, Tra, are you there?
Hi, Andra. Yes, I'm here. Hi. Thanks for having me back.
Oh, it's a pleasure to have you back again. You were here on our first COVID-19 Robots and Us, and you were talking about deploying OhmniLabs robots in hospitals and other facilities. Can you tell us more about that? And also, I saw on your website that you've got a giveaway.
Yes, absolutely. So if you don't mind, I'm going to share my screen here so that I can walk through it. And today is the day that we are launching the donation program, even though it has been available on our website for a little while, but our marketing campaign is now available for to outreach to more nurses and hospitals and those in need. So I think in the first conversation we had talked about how OhmniLabs is helping delivering the human connections between healthcare workers and patients, and also connecting families with patients. And we continue to do that across the board. And now we are getting more involved in Asia, as Asia is unfortunately seeing a second wave of infections with COVID-19. So we actually are providing a lot more robots to Singapore these days. So that's our continued effort on that front. We are also part of the helpful engineering volunteering group, and it's been really wonderful to be able to support the face shields initiative. And we actually just brought up 18 more 3D printers in the Silicon Valley Robotics facility. So those printers, we're going to dedicate a lot more to the face shield project. So thank you, Adler. Thank you, Wee. It's been awesome working with helpful engineering. So to what Andra just mentioned. So today is the National Nurses Day. And with that, we would like to thank our healthcare heroes with a donation program. And we are donating 5 to begin with. And we really want to see how effective this will be, because we certainly can do more. And we'll try to do as much as possible within the realm of possibility for a small business, a small startup like us in Silicon Valley. But hopefully, if you are, if you're listening, you know, if you have a nurse or doctors or hospital that you would like to nominate, I would encourage you all to please do so. And I will put the link on here as well. So it's on our website, of course, under the healthcare solutions. And from there, you can navigate to this page, which is the donation page. And we encourage you to watch a little video explaining what Omni telepresent robots can do for these organizations and why we are supporting them with this donation.
Oh, that's wonderful. And what timing. So first off, happy National Nurses Day. If anybody here is a healthcare worker, you have our gratitude. And if anybody here is not a healthcare worker but knows a healthcare worker, here is the way you can thank them. That is brilliant. We will definitely make sure that everybody's got that link. And in fact, Erin's been putting some good links in chat as well. We'll make sure that's here. And what has been the, you know, you've had, what's really changed in the last 2 months? You know, are you finding that you're working all hours of the day to meet this demand? Or are you able to stop and, you know, really enjoy some of your successes along the way? Or do you have lots of new ideas for new projects that you want to do? Where are you at now?
So we're not taking any breaks, that's for sure. We are just pushing the boundaries of our own team here. So we are expanding the facility in order to produce more robots. As you know, we also produce the Avatar NUMI robots that's made by OhmniLabs. And so there is a lot more demand now for that Avatar robots in the context of healthcare in Japan, also in graduations. So we actually working to expand our facility in this time, which is a little bit tough to do, but we're certainly working on that. And in terms of products that we could do that are more specialized in healthcare, so we're having an initiative to produce a very specific Omni Health product, and that product is going to have quite a lot of integrations with existing medical devices. So it's in the works, so can't really share too much detail at this moment, but we're working very hard on that project.
That's wonderful. Well, I look forward to hearing more about that when you can say more about that. And in the meantime, though, thank you so much. We're going to go to Mark, and I didn't really introduce you so well. Tra Vu is the COO of OhmniLabs. So she's very, very experienced at robot companies, robot building. And now over to Mark Martin, Industry Workforce Development at the California Community Colleges and Bay Area Manufacturers Discussion Forum.
Great, thanks, Andra. I really appreciate it. Yeah, so it's kind of interesting because what I do is I work in the Bay Area Community Colleges around workforce development. So I place people into jobs in manufacturing. I'm focused on manufacturing. So why am I here? So let me give you a little, one quick thing on the project I'm working on around COVID, which is a face shield, which we worked on at the Fab Lab at Laney Colleges, which is one of the colleges I work on. And we start off with 3D printing, which is, you know, quick. We could do a lot. There were a lot of designs out there when we were working on that. Me being based in kind of manufacturing background said, you know, that's great, but to do it in volume, we need to do injection molding. So we moved to an injection molding design. And this is an injection molded design, which is based on Stratasys, but without 3D printing, we couldn't have rapidly prototyped and come up with new ideas on it. So that's great. Our injection mold, and this is all going to wrap back into robotics here. Our injection mold is still en route. Okay, so it got done. We had a rapid turnaround on the design and on the local company that was offered to front all the money for it, but their molder was in China. Because if you want to get, you know, relatively inexpensive, but still high quality molds, you go to China. And because of the supply chain, because of the cost of air shipping, you know, which normally only takes a couple days and maybe a couple days through custom, you can do that. You can work that on a normal basis. But now we're kind of stuck in this mode of waiting for it. So it's going to be the end of May before we get it. But then we'll be able to produce. There may not be quite the demand, hopefully not, but we'll be there in case. This is kind of the plan C that Dale was talking about. And we had people liberate 3D printers as well and take them and put them in their roommate's bedroom while they were away in order to kind of do the prototyping. But this is the thing is how I think this leads kind of to what robotics and how it works with us. So I work a lot with manufacturers and placing people. Two things we're going to see. One is that we will see some more manufacturing moving back to the United States because of this. There's always a little bit of that. There was started to be some cost parities with China, not direct labor costs, but when you look at all the shipping costs and quality costs and everything. And now we're starting to see that supply chain resiliency. I think Intel is actually discussing moving some of, or not necessarily moving, but the next round of building some of their chip factories in the US because of the concerns about the supply chain disruptions from the Department of Defense and others. So you're going to start to see more of that. And when you see that, people are still going to want to start to look at how do you reduce the costs of manufacturing that stuff. And whereas people in robotics know that human is extremely flexible and can do a lot of things that are hard to do in robotics. And so sometimes the cost of humans is actually cheaper than robotics for that, because of that flexibility. Now we're starting to see these factories move back, and there might be more opportunities. There's the ROI for a robot is now been increased because we do have higher labor costs here in the United States. And the second thing that's happening, even those companies that are sitting here now manufacturing have to reconfigure for safe social distancing. Whether or not that's going to be a long-term issue, it's certainly going to be a short-term issue. Tesla is slowing down their factory so that they can space more people out. And now, again, you have this ROI that has just had a step change function for robotics that to step in and say, well, it didn't quite make sense there before. Tesla actually put in a lot of robotics and then pulled some of it out because they discovered that, again, humans are really good at being flexible and doing these tasks. But now if you're talking about having to slow the factory down because you can't put humans close to each other, if you can stick a robot, every other station or somehow limit that human to human contact, then again, it's going to increase their speed. And so they're going to be much more willing to pay for it. And so that's what I think is what I'm going to see happening with kind of manufacturing workforce in the United States. Is we're going to start to see, again, robots starting to be more cost effective based on these new inputs from COVID. And it will also, from the workforce side, it's going to mean we're going to need more people to maintain those robots, which is one of the things that we work on in the community colleges around maintenance. So,
and we'll need more people to build those robots as well. So I'm hoping for a lot of workforce expansion in the field of robotics, because I see just a huge growth in demand, and it's not always very high skilled, the jobs around building and running robots. It can often be tending rather than, say, programming. And so I think you're right about the trends changing. We saw in retail a trend just starting to emerge towards micro fulfillment, and I believe that we're seeing a trend towards, or we will be seeing a trend towards, micro factories as well. And it's just a collision between, on the one hand, I'm in makerspaces who are talking about buying injection molding equipment and die cutters, because once you start really producing things, a laser cutter doesn't cut it, pardon the joke. And to look at what are really volunteer-based groups adapting and moving in towards the real manufacturing equipment at the same time as manufacturers getting more interested in robots. I think this is a wonderful kind of connection.
Yeah, and it's really going to be interesting to see, because if companies, if you want to make a circuit board, in volume, you might start here in the US and outsource it over to Mexico or to China. And, especially with China, with that supply chain disruption, if you're a robotics manufacturer, you might say, we're going to keep it here. It might be a little bit more expensive, but we reduce the risks of those supply chain disruptions. And then if you're doing the boards here, you start to see it might make more sense to source the components for those boards here. Or, certainly if you're talking mechanical components, just, you're going to do the local machining here versus if you're shipping it from overseas, they're going to be machining it over there. So it can have some kind of escalating effects like that on the supply chain.
Fascinating. Now, Ken, can we go over to you? Ken Goldberg, Director of the People and Robots Initiative at CITRIS at the UC Berkeley.
Thank you, Andra. Yes, I've been just stunned and pleased again at listening to the array of incredible guests that you've brought together tonight and all their different perspectives. And I want to say, I think actually that this is something that you really deserve our huge thanks from all of us who've been participating and listening to this series, that you got started on it 8 weeks ago at a very early stage. You persevered at bringing together a really interesting and diverse group of minds and perspectives, and the kind of ingenuity and creativity that has been discussed on this series has been is so inspiring to see how people have come together and thought about different aspects of these problems, how everybody has tried to find a way to contribute and do something constructive is just very reassuring. I've been thinking a little bit about how, before this started, there was so much fear out there around robots, that was an AI, that there was a lot of rhetoric, that we were in danger of, that humans may be obsolete. Super minds and singularity, and all this fear was sort of concentrated in a certain direction. And it's been so interesting to see how that has completely shifted now. I mean, you don't hear about that at all. It's not really on people's minds, I think. And it's much more, this has been a wake-up call to help us all put that into perspective, that there are much more important things in some sense to worry about, that we're much more vulnerable to. And in some sense that robots have a positive role to play here, that they can provide disinfectants, they can provide telehealth, they can help manufacture very quickly and ramp up for new supplies. And I think that is actually, as Mark was saying, that's changing the perception in a very profound way, that we're starting to see new robots in a new way. And we've talked about robots for food preparation, robots in manufacturing, delivery. And I think now we're starting to realize that this is going to be with us for a very long time. And so the need to disinfect airplanes, hotel rooms, and all of our environments is going to be so important. And having tools that can help remind us, that can track where surfaces, where people have been touching surfaces, would be really interesting. And I think robotics, computer vision, the tools that are out there will be there to assist us much more than to replace us altogether. So I do see that we'll see robots more in factories and warehouses, but we'll always need humans in these jobs. So just have to space, the humans will have to be separated. So I think there's the opportunity that robots can help fill those gaps for us, and not only in the near term, but really long term. So that's what I've been just watching this unfold over this 8 weeks. And I want to thank you and everyone involved, but you in particular, because you've really been a steady voice, curating, bringing people together, finding the connections, and it's really been a terrific series. So I think we all appreciate it. And I want to say on behalf of all of us, thank you.
Well, thank you so much, Ken. And I really appreciate your comments. You round out the evening beautifully, and you always leave us on a positive and inspiring note. And I think, as I've been talking to people on behalf of Silicon Valley Robotics, facing those fears, facing people saying, but won't robots replace us, take our jobs, or do other negative things? First off, I knew the chances were pretty small, but second off, thinking about this in a large scale, the way to have robots that are good robots, not bad robots, is to make robots that are doing good things. And I think that if we focus on developing robots for constructive and positive applications, then negative is going to be a very secondary impact. And we have so many things that are global challenges that we do need to have some sort of extra superpowers to help us solve. And I always want to look at robotics in that respect as, you know, our extra superpower to help us solve the human problems that we have, and, you know, to keep the human in the loop. Now, I think we've hit the howling in the background that, and is this just a Berkeley thing, or is this happening all across the Bay Area?
I don't know, actually. I don't know. I've heard other people are howling. New York is clapping. I think everybody needs some kind of outlet here to do it. I'm sorry we're going to stop. This is the end of this series. But as you mentioned, I'm excited about next week, the symposium. We'll invite everyone to that. And I hope that you do things like this in the future. Maybe after taking a break, you'll pick up and do another version of this. But I think this kind of thing is really important for us to be able to come together and talk about these issues as they evolve.
Thank you. And we will be doing more. Next week, we have the open problems for robots in surgery and healthcare, and the link is in the chat. We are also having the first online robotics job fair. We will have one a month for the next 3 months on May 20th, and the link is in the chat. And we definitely have some ideas for some other really great discussions in the same format around robots. That's not going to stop. It's just, we're going to think maybe about some of the other impacts. And every speaker here today raised topics that I would love to follow up in more depth. So I'm looking forward to doing a deeper dive into some of those topics in the future. And thank you, everybody. Thank you for joining us and sharing great questions and just being part of the event. I look forward to the next one.